Today we're going to look at section 4.2, graphing quadratics in vertex and intercept form. Our objective is to be able to graph a quadratic in vertex and intercept form and to be able to find important information like the direction, y-intercept, x-intercepts, and vertex. We're not going to stress the x-intercept as much today, but we will get into it later in this chapter. So vertex form, okay, looks like this. F of x equals a times the quantity x minus h squared plus k. And the reason it's called vertex form, because I can just look at this equation and find my vertex, the point x, x comma y, we get from looking at the h and the k, and that's where our vertex comes from. But we can also find other important information from this equation, like the direction it faces. Does a parabola face up or down? And it faces up if a is positive, just like in standard form. And it faces down if a is negative. Our vertex, like we just talked about, is the point h comma k. Now, we're not going to spend a whole lot of time on this, but to find an x-intercept, every x-intercept occurs where y, or in this case, f of x equals 0. So if we did want to solve for our x-intercept, what we would do is we would set y, or f of x, equal to 0, okay, and then try to isolate the x by moving everything to the other side. Y-intercept, though, we can find by substituting in 0 for x. Now, this is not as easy as it was in standard form, because in standard form, we just had 0 comma c. The c value was our y-intercept. In this case, we truly do have to do a little bit more simplifying. What I'm going to do is anywhere I see an x, I'm going to substitute in a 0, and then evaluate by simplifying the right-hand side. Now, what I mean by other points is a parabola is made up of an infinite number of points, and you can find any of them by substituting in your input, or an x value, and finding the corresponding output, or y value. So let's go through 4 examples of the equation when it's in what we call vertex form. So the first thing we're going to notice is that this is going to face up. It's going to have a vertex at 3, negative 8. Okay. Whenever we're finding a vertex, we do the opposite. So it says x minus 3, so we make it a positive 3 because the h is after the negative, and then we just write negative 8. So I'm going to go to 3, negative 8. Okay. The next thing I'm going to find is the y-intercept. Now to find the y-intercept, all I'm going to do is substitute in a 0 for x and solve. So remember, our y is the same thing as f of x, our output. So I'm just going to substitute in a 0 and do the algebra. This is going to be negative 3 squared, which is 9. 9 times 2 is 18. 18 minus 8 is 10. So I can plot the point 0, 10. And now that I have that, I can find its corresponding symmetric point, because a parabola is symmetric. So I'm going to get a point on the right-hand side of my imaginary axis of symmetry. And then all I'm going to do is draw a light sketch. Now I should be able to see that this parabola crosses the x-axis at 2 places, here and here. And if I was to actually set 0, I was going to substitute that in for f of x and solve, I would get these 2 points, which we're going to do later in the chapter. Okay, example 2, or example B. This one faces down because my a is a negative 1. My vertex is a negative 1, comma, a positive 7. And now I'm going to find my y-intercept. I'm going to get that by substituting 0 in for x. So f of x is equal to negative 0 plus 1, quantity squared, plus 7. Okay, and if it helps you to put a negative 1 here so you don't make a mistake, do that. 0 plus 1 is 1. 1 squared is 1. 1 times negative 1 is negative 1. So negative 1 plus 7 gives me a positive 6. So I get my y-intercept at 0, 6, which means its symmetric point is at negative 2, 6. And then I can just go ahead and do a light sketch of my parabola. Again, the more points you have for your parabola, the more accurate it gets. And we can tell here that if I was to solve this, I should get 2 solutions for x if I solve this. And you might think, well, how do I get 2 from solving this? What we're going to talk about later in chapter is, remember, to get x by itself, at some point we're going to have to take the square root of both sides. And when you take the square root of both sides of an equation, we get plus or minus our answer. So that's going to give us our 2 solutions. Let's look at our third example. This one is going to face up because we have a positive 1/5. My vertex is going to be at negative 5, comma 1. I'm going to go -5, up 1. To find my y-intercept, I'm just going to substitute in a 0 for x. And when I do that, I'm going to do a little bit of algebra, so we're going to get a little f of x is equal to 1/5 times the quantity 0 plus 5 squared plus 1. 0 plus 5 is 5. 5 squared is 25. 1/5 of 25 is 5. So I'm going to get 5 plus 1, which is 6. So if I go to 0, 6, that's the the y-intercept, which means my symmetric point would be -10, 6. So now I can graph my upward facing parabola. Again, make sure you put arrows on this because it does go on forever even though it's off your graph. And that's our light sketch. If you notice here, our parabola does not cross the x-axis at all. But what is that going to show when I actually solve? If I substitute in a 0, we're going to get an answer that's imaginary. And I know we talked about imaginary the first day of class, and I told you it'd be coming up later in this chapter. But that's the algebra's way of telling us that, you know what, you're trying to solve for something that doesn't exist, so they give us an imaginary number. And like I said, we'll talk more about that later in this chapter. And let's try the last example. This is going to be a downward facing parabola. Its vertex is going to be at 6, -4. Again, opposite, and then just rewrite, I'm sorry, +4. It's going to be 6, 4. So I'm going to go to 6, up 4. I'm going to find my y-intercept. Substitute in 0 for x, and then we're going to solve for f of x. So we get -1/3 times 0 minus 6 squared plus 4. 0 minus 6 is -6. -6 squared is 36. If I do -1/3 of 36, I'm going to get -12. -12 plus 4 is -8. So I'm going to go to 0, -8. Now, if you look here, the symmetric point would be at 12, -8. So that would be off my screen a little bit, off my graph, which is okay. It doesn't mean it doesn't exist. It just means that I gave you a 10 by 10. Now, you could always change the scale of your graph to make sure it fits. You could go by 2s. But if you ever change the scale, please make sure that you state somewhere on your graph that you did change the scale. So now that we've talked about vertex form, we're going to go on to what we call intercept form. It's a very nice form because actually finding x-intercepts usually is the hardest thing. It takes the most algebra. But in intercept form, they already did the work for you. And if you notice that the form looks much different, you don't even see an x squared. And this should be right here. This should also be an x. Sorry about that. Okay. So you should have f of x equals a times x minus m times the quantity x minus n. Now, we're going to get, the reason it's called intercept form is because we can find our x-intercepts really easily from this. Okay? It's m comma 0 and n comma 0. Okay? M and n are our x-intercepts. Okay? And we get this because, remember, an x-intercept is when y is 0. So if I set this equal to 0, okay, let's just forget about the a for a second. Whenever you have product equal to 0, so things multiplied equal to 0, the only way you can get 0 by multiplying things together is either the first is 0 or the second is 0, or if there's 5 things, first, second, third, fourth, fifth, one of these has to be 0 in order to get 0. So if you remember, this is called the zero product property. So if I have x minus m equals 0, okay, or x minus n is equal to 0. So I get x equals n, x equals m, and that's why these are my x-intercepts. Again, this is called the zero product property, and it should hopefully look a little familiar when we go through the problems. So how do we find this information? Again, let me change this to an x. Direction is the same thing. If a is positive, this is going to go up. If a is negative, this is going to face down. Okay, to find the vertex, okay, I'm going to kind of just write out, we're going to average the x-intercepts to find our x value. And when we go through a graph, you'll be able to see it a little better. Once I find the x value, I can always substitute it back into my problem to find the y value. Because remember, a vertex is just x comma y. To find the x-intercepts, well, we just talked about that. It's going to be m comma 0 and n comma 0 in this case. To find the y-intercept, it's just like always. I'm going to substitute in 0 for wherever my x's are. So in this case, there's 2 of them. So if I'm going to solve this, I'm going to put in 0 for the first x and 0 for the second x. Simplify the right-hand side to find my y value. And like always, to find any other point on the graph, you can always pick any x value, any input, substitute it into our equation, and then find its corresponding output. So let's go through like 4 examples just so you can get an idea of how to graph these. And again, we're just doing light sketches. So if I look at this one's going to face up. Okay, now this is a little bit different. I'm not going to find my vertex first. I'm actually going to find my x-intercepts. Okay, since this is intercept form and not vertex form. So my x-intercepts would be 6 comma 0. Okay, because the 6 is after the minus sign. Now if you look here, there is no minus sign, but if you remember from when we talked about absolute values, this is the same thing as x minus a negative 4. So this would be x minus 4. And again, remember what we're doing is setting this equal to 0 and solving. So you set x minus 6 equal to 0 and solve, x plus 4 equal to 0 and solve, and we get 6 and negative 4. Oops, I'm sorry. Why I wrote it that way. Let's write it as an actual point. So 6 comma 0 and negative 4 comma 0. So I'm going to go and graph those. Here's 6, 0 and negative 4, 0. That is where my parabola crosses the x-axis. Well, if you remember, a parabola is symmetric, which means that these 2 points, okay, are the same distance away from my imaginary axis symmetry, and that axis symmetry goes through the vertex. So if I average these 2 points, negative 4 plus 6 divided by 2, okay, negative 4 plus 6 is 2, 2 divided by 2 is 1, that's the average. So that means my vertex is going to be somewhere along the line x equals 1, because this is the point that's smack dab in the middle. So now that I have that, I know my vertex is at 1 comma something. Well, if I know it's at 1, just like what we did in standard form, once I find the x, I can substitute it back in to find the y. So this could be 1/4 times 1 minus 6 times 1 plus 4. So this could be negative 5 times 5, and this could be 1/4 of a negative 25, okay, which is negative 25 over 4. So the easier way to look at this is probably not, if you don't have a calculator, change this to a mixed number. That might make it a little easier. So this would be negative 6, okay, and 1/4. So I'm going to go to, it's at 1 and negative 1, 2, 3, 4, 5, 6 and a quarter. Okay. That's where my vertex is. Okay. Now I could find the y-intercept. Again, to find the y-intercept, all I'm going to do, if I wanted to find an extra point, and this isn't enough to actually graph it, but just to kind of show you, I'm going to substitute in 0 for x. If I substitute in 0 for x, I'm going to get 1/4 times negative 6, because 0 minus 6, times 0 plus 4 is 4, 1/4 of negative 24. So I'm going to get 1/4 of negative 24 is negative 6. So if you look, negative 6 is my y-intercept, which means I can find its symmetric point. So this one I can actually get a few more points rather easily and get a nice sketch. Let's go through another one. This one's going to face down, and my x-intercepts, I'm going to have 2 of them, is going to be a negative 5, 0 and a positive 5, 0. Okay, again, one should be positive. I don't know why one should be negative. Sorry, on your note sheet it should show 1 positive, 1 negative. So I'm going to get a negative 5, 0 and a positive 5, 0. So I'm going to go to negative 5, 0 and positive 5, 0. So I know the point that's right in the middle would be at 0. So I know that my vertex falls along this line, but I don't know where. So I know my vertex is at 0 comma something. So if I take this problem and I substitute in a 0 for my x value, I'm going to get negative 0 plus 5 times 0 minus 5. And I'm going to get negative times 5 times negative 5. And it's going to be a positive 25. But 25 really doesn't fit on here. So what could I do to actually graph it? Well, you don't have to change both scales, but I could change this scale and say by 5s. which means if I need to go up 25, I'm really going to go up 1, 2, 3, 4, 5, and there's my vertex. But I have to state that this axis is going by 5s. So now I can do a light sketch, and I don't have to worry about solving for my y-intercept because I know this is my y-intercept. Because remember, a y-intercept is when x is 0, which just happens to be the same as my vertex. Let's look at a third example. So I know this is going to face down, and I'm going to have my x-intercepts are going to be at 8, 0, and 6, 0. Okay, that's what I get when I set each of these equal to 0. So I'm going to go to 8, 0, and 6, 0. Well, I can tell right away that my vertex has to be in between them, which is going to be at x equals 7. So to find my vertex, I know it's going to be 7 comma something. So I'm going to just take and substitute in 7. So I'm going to get negative 5 times 7 minus 8 times 7 minus 6. Well, this is going to be negative 5 times 7 minus 8 is negative 1. 7 minus 6 is a positive 1. So if I multiply all this together, I'm going to get a positive 5. So I'm going to go to 7, 5. Okay. Now, I'm going to graph this, and there's my light sketch. Again, I could find the y-intercept by substituting in 0 for x. But if I look at that, if I substitute in 0 for x, I'm going to get negative 5 times negative 8 times negative 6. I'm going to get a very large negative number. And as you can tell, it's going to take a little while before it hits the x-axis. Or sorry, hits the y-axis. So we're not going to worry about that one because we have enough points for our sketch. And our last example. This faces up. I know my x-intercepts are going to be at negative 1, 0, and negative 6, 0. We go to negative 1 and negative 6. Okay, so what point falls right between this? So again, we're just taking averages. If you want to do this, 1, 2, 3, 4, 5. That's 5 spaces. Or, well, half of 5 spaces is 2.5. So I'm going to go 1, 2.5. So I know my axis symmetry is right here at negative 3.5. Or again, we're just taking an average of our two x-intercepts. So if I average negative 1 and negative 6, that's negative 1 plus negative 6, which is negative 7, divided by 2 is negative 3.5. So my vertex is going to be at negative 3.5, or 3.5, comma, and now I'm just going to substitute it in. I have 1 half times negative 3.5 plus 1 times negative 3.5 plus 6. This is going to be a negative 2.5. This is going to give me a positive 2.5. If I take the time to evaluate that, you can use your calculator to kind of help you out. We get a value of negative 3.125, or that's equivalent to negative 25/8. Both of these are acceptable answers because I didn't have to round it, so I'm just going to use the decimal for us right now. Okay. So I know at negative 3 I'm going to go down 1, 2, 3, and just a tiny bit. All right. If I wanted to find the y-intercept, because the numbers are small enough, I'm going to substitute in 0 for my x. I'm going to get 1 half times 0 plus 1 times 0 plus 6, which is going to be 1 half times 1 times 6, which is 3. So I'm going to get a y-intercept at 0, 3, which means the symmetric would be at 7, 3, just to give us a little bit more accuracy in practice finding it in different equations. So this one I can get some accurate points and try to lightly put a graph in there. So hopefully feel a little